This is a recorded reading of Building Your Knowledge, Forces in Motion. Speed, acceleration are two quantities that can describe an object's motion. However, this description is not complete. To understand the causes of change in motion, it helps to turn to a simple example. Think about a book lying on a table. If you push the book to the left, it moves to the left. If you push the book to the right, it moves to the right. These examples are, of course, assuming you both push the book hard. Scientists use the term force for push or pull between objects. So to summarize this paragraph, they're really just describing what the term force is, and that's a push or a pull between objects. However, applying a force does not always result in motion. For example, if you and a friend both push the book equally hard in opposite directions, the book does not move. In this case, two forces are being applied to the book, but they are acting in opposite directions. One force cancels out the other, so the book does not move. Therefore, you have to account for all the forces on an object before you can predict its motion. One key part in this paragraph explains that objects that are not in motion can still have forces being applied to them, and we'll learn how in the next paragraph and diagram. When you add all the forces acting on an object, the sum of the force is called the net force on an object. You can use diagrams to help you add up the net force on an object. Typical diagrams depict the individual forces as arrows. An arrow's length represents the strength of a force, and the arrow's direction represents the direction of force. The strength of opposing forces is often indicated using negative and positive numbers, with a negative force being in the opposite direction from a positive force. You need to know both the strength and the direction of all forces to determine the net force acting on an object. Then you will be able to predict the object's motion. Just like acceleration, force is a common word you have probably heard before, but has a very specific meaning in science. So what this paragraph is trying to tell you is, first off, the definition of a net force. And the net force is the sum of all of the forces acting on the object. Secondly, it's also having you understand what the arrow length and head mean. The arrow's length represents the strength. So an arrow with a longer length represents a stronger force. And the arrow's direction represents the direction of force. So this arrow up here is going to the right, and therefore it's a force going to the right. Finally, in this section down here, it talks about using negative and positive numbers, which we won't be doing in Science 8. So let's page down here for an example. You have two objects. The top object is above the red line, and the force, there's a right force of 8 newtons to the right. Now, it writes out to the right force, but in the future you just get arrows. It has 8 newtons. 8 is the strength, and newtons is the unit of that strength, the unit of the force. Newtons is capital N for newtons. And there's also a left force pointing in the opposite direction with the same amount of force. So because both of these forces are the same in number and size, but different directions, you aren't going to get motion. The book won't move off the table. To describe an object that does not have a change in motion, you're going to say that its net force is 0. Another thing to do is just to calculate 8 minus 8 newtons equals 0 newtons. Okay, so now let's look at the example down below the red line. You have a new book, and you have a right force of 2 newtons to the right. And you can actually see the arrow is a lot smaller. The length of the arrow is smaller because the force is smaller. And the arrowhead is pointing to the right. You've also got a left force of 8 newtons. 8 newtons is bigger than 2 newtons, so the length of the arrow is going to be longer. And because that force is going to the left, the arrow is going to be pointing to the left. To calculate the net force, you'll take the bigger number, 8, minus the smaller number, 2, and you get equals 6 newtons. So you'll write 6 newtons. My pen won't work, but yours will. And because the larger force is coming from the left, it'll be 6 newtons to the left. In the future, you will be identifying the type of force, which we'll teach you in future lessons, but right now you'll just be identifying the net force. If the net force is 0, the object will continue to do what it's doing. And at this point in time, this book is not moving, so it'll continue to not move. If the net force is greater than 0, let's say if it's 0.5 newtons or 6 newtons or 7 newtons, the motion will change. And when an object's motion changes, it's either going to accelerate. So its speed will change or its direction. This concludes the forces and motion reading. If you have any questions, ask your teacher. Have a great day.